Here's a sound wave, and here's its inverse. Combine them, and you have silence. That's the basic idea behind noise-canceling headphones. But it takes a lot of technology to make that seemingly simple science possible.
We have 15 millionths of a second to measure the noise, run it through a little DSP processor, compute that inverse signal, and pop it out through the driver.
Here's how they work.
One way to visualize acoustic waves that I like to use is a slinky.
John Rule has spent the last decade developing new algorithms for personalizing noise cancellation performance in Bose headphones.
We draw them as sine waves as if something's going back and forth or up and down. But what's really happening is that these vibrations are actually propagating through the air. The medium has stayed fixed, but you can see that pulse of energy sort of running through the length of it.
Because sound is just waves, you can cancel a sound wave by introducing an equal and opposite wave.
So what you've got is, you've got an incoming sound wave, and the way destructive interference works is we say, hey, if I could generate an equal and opposite signal, right? I could generate the signal that's the inverse of that, and if I sum those two things together, I'll be left with a flat line. I'll be left with zero pressure, and that will be interpreted by my brain as the noise having been canceled.
Bose was the first company to develop noise reduction technology for headphones.
Dr. Bose was coming back on an overseas flight and got very frustrated by the fact that airplanes were very noisy. We can control all sorts of other stuff. Why can't we control noise? The first application that we looked at was canceling noise on airplanes.
Pilots wore its earliest prototypes in 1986. While the technology has gotten more sophisticated, the basic science remains the same. Active noise cancellation requires a few main components: an outer microphone to track incoming noise, an inner microphone that tracks sound waves that make it inside your ear and also checks if more environmental noise than expected is making it through, a digital signal processor to run some algorithms based on data from the mics, and the speaker, which cancels the background noise while also playing the music or sound you want to hear.
Think about how fast this has to happen. The sound is obviously propagating at the speed of sound, right, which is 343 meters per second. If you think about that in terms of the thickness of an earbud, it's getting from the outside of the earbud to the inside of the earbud in about 15 microseconds. So that's millionths of a second. We're doing math as fast as we can to basically cancel it out before it gets in.
Because everyone's ears are differently shaped, active noise cancellation requires algorithms that can be tuned based on the user. Bose, for instance, does this by playing a welcome chime and monitoring feedback from the internal microphone to customize noise-canceling filters accordingly. This requires a lot of testing to make sure the algorithms work on a wide range of users in all types of noisy environments. But eliminating background noise is just the first step. The next is figuring out what noise to remove, based on the context.
I think it's really important to recognize that noise is not bad. Noise is critical to my brain, critical to my body. My brain uses it to create richer experiences, to fill in what's missing, which is all the time.
Poppy Crum was previously the chief scientist at Dolby Laboratories, where she worked for more than a decade. She's led teams focused on emergent technologies and platforms that impact sensory systems.
When you think about noise canceling technology, I like to sort of separate it into three different categories. You know, there's passive noise canceling or passive noise reduction, which is effectively an earplug. The second layer would be active noise reduction. It's dynamic to the system, but it's dealing with what we would call stationary sound. Sounds that are, consistent, they're continuous, or they're predictable. Examples of that might be a generator or airplane noise. Not all the sounds in the airplane, but that general rumble, those low frequency sounds you're trying to get rid of. They're pretty predictable.
For these predictable noises, current noise canceling algorithms can quickly identify unwanted sound waves and cancel them out. Beyond that, things get harder.
And then the next layer, which is I think where, the future is still evolving, is when you start being able to really cancel out things that are what you would call non-stationary noise. Things that might be a dog barking. And, those elements that happen where you can't predict them and you might be able to have an expectation that they're going to happen, but they're things that aren't continuous and aren't constant.
But sometimes, after your technology has gone through so many steps to reduce background noise, you want it back. AirPods Pro have a transparency mode where they recreate the normal sound of your environment. Other noise-canceling earbuds also offer modes to help you hear your surroundings, like Bose's Aware Mode and Sony's Ambient Sound Mode that preserve enough background noise to keep you alert to your surroundings.
When you build a technology that's supposed to map to a human experience, you need to understand how the human system perceives change or perceives that element you're building, and then that becomes how your algorithm behaves so that you have a continuous experience of the world. So you need labs where you can remove or control every other element.
Noise cancellation could soon solve more complex problems, like using machine learning to seamlessly and intelligently eliminate unwanted sounds or voices across various contexts. Adaptive audio, which is coming to Apple's AirPods Pro soon, combines noise cancellation with the transparency mode, so you can only hear the important sounds around you.
So you can stay present within your environment while distracting noises are automatically reduced.
It's the thing that everybody wants, right? They want to make certain noises go away. So they still want to hear some things, they don't want to hear other things. And can you just give me a set of headphones that, just cancels the stuff I don't want to hear? That's not a thing that we're offering yet, but that's the kind of thing that is being worked on.